We're going to take a look at lesson 3 and 4 again. So lesson 3 was just solving inequalities. Lesson 4 was inequality word problems. For the solving inequalities, we're not going to worry about the graphing. We are simply going to focus on the actual solving process. Just like we did for equations, I am going to highlight my variables. I'm going to do all 4 of them on this front page. And I'm going to draw my line. This time, instead of down the equal sign, down the inequality symbol. And our process should be the same. So looking on the side with our variable, the operation that we have is subtraction, so the opposite is to add. And we always do it with the number that's with the variable. If we were subtracting 30, the opposite is to add 30 to both sides. On the side with our variable, it should cancel. We're left with D. I'm going to bring down my inequality symbol, and then 32 plus 30 is 62. Number 2, on the side with our variable, we have the operation subtraction. The opposite of subtracting is to add. We always add the number with the variable. So 13's on that side. We are adding 13 to both sides. The 13's cancel each other out so that x is alone. Bring down our inequality symbol. 25 plus 13 is 38. Number 3, on our variables on the right side now. When we look here, the operation that I see is addition. The opposite of adding is to subtract. So since 12's on the side with the variable, instead of adding 12, we're going to subtract 12 from both sides. Our x is left alone on the right side. I'm bringing down my inequality symbol, and here, 50 minus 12 is 38. You can leave it like this. It's good to get in the habit of flipping it around, though, so that it matches your graph. Because I want my variable on the left, and it's not right now. So I'm going to move x to the left. I'm going to move 38 to the right. When I flip those, I'm also going to flip my sign around. The point is still next to the 38, so we didn't really change the value. Okay, number 4. On the side with our variable, the operation we have is addition. The opposite is to subtract. If we were adding 41, the opposite is to subtract 41 from both sides. On the side with the variable, those cancel. We're left with y. I'm going to bring down my inequality symbol. 60 minus 41 is 19. We can leave our answer like this, but just like the previous problem, I want to flip it so my y is on the left. So I'm going to move y to the left. I'm going to move 19 to the right, but since I flipped those, I need to flip my sign. Okay. Number 5, or actually first, for all of these, I'm going to highlight my variables first for all 4 of these. And I'm going to draw my line down my inequality. Okay, on this side, my x is right next to the number, which means multiplication. So the opposite is to divide. Remember, we want to get away from using the division symbol. So I'm going to use a fraction bar and divide each side by the number with the variable. So dividing each side by 4. 4 divided by 4 cancels out to 1, or just 1x, or just x. I'm bringing down my inequality symbol. And then I'm plugging in 72 divided by 4 is 18. Just like the previous 2, I can leave my answer like this. I'm going to flip it around so my x is on the left. So I'm moving x to the left, 18 to the right. When I flipped those, I'm also going to flip the sign. My point is still by the 18, so we're good. Number 6, my number is right next to my variable. That means multiplication. The opposite is to divide. We're not using the division symbol. We are using the fraction bar. The number that's with the variable is 5. So we're dividing each side by 5. Those 5's cancel each other out to just 1x, or just x. I bring down my symbol, and then I calculate. 95 divided by 5 is 19. I can leave my answer like this, but to make it easier when we're graphing, I'm going to flip it around. I'm going to move my x to the left, my 19 to the right. When I flip those, we're also going to flip the sign around. All right, last two for just solving, then we're going to look at word problems. Looking at the side with our variable on it, x is being divided by 3. That's what that fraction bar means. So the opposite is going to be to multiply. We're getting away from using x for multiplication because that looks like a variable. Instead, we're using parentheses to show that we're multiplying. The number with the variable, x is being divided by 3, so that's the number we're going to multiply both sides by. Those 3's cancel each other out to be just x. I bring down my inequality symbol and I multiply. 12 times 3 is 36. Okay, number 8. Looking at our variable, we have that fraction bar, which means division is in the problem. So the opposite for solving is to multiply. Again, we're using parentheses to show multiplication, not x. X is being divided by 8, so the number we're multiplying by is 8. The 8's will cancel out on this side with the variable to leave x on its own. Bring down our inequality symbol, and then calculate. 7 times 8 is 56. Let's look at word problems now. So we did some of the graphing and all that for you just to make it a little bit easier, but we're still gonna focus on the defining the variables and writing those inequalities and then answering the questions related to it. We put the cheat sheet here. As a reminder, you have your cheat sheet in your packet as well. Adam is renting a DJ for $18 per hour and wants to spend at most $270. So first we circled the numbers. Now we're gonna look for those keywords. What's important is we pointed out the inequality keywords. You also want those equations keywords as well. Adding and subtracting are pretty easy to find. Remember those keywords for multiplication as well. So when I look at this, I see at most, which I'm going to highlight, and I see at most over here, and I see the word per, which according to my equations cheat sheet, per tells me multiplication. So that means multiplication, and if I look here, at most told me this inequality symbol. Now, for defining my variable, I'm gonna look by my operation. It says $18 per hour. So for my variable, I'm gonna say H equals the number of hours. Writing our inequality, just like we did for equations, I'm gonna put my total first. So my 270, I'm gonna put all the way at the right. But instead of an equal sign, we're using that inequality symbol that we already pointed out. Now on the left, $18 per hour, we're doing 18 times our variable H, which means we are just writing it directly next to each other, 18H. Normally we would have you solve. We did the work for you here just so we can talk about what these things mean. So when this is solved, you get that H is less than or equal to 15, and we graphed that right here. So now we gotta answer this question. Would Adam be able to rent the DJ for 17 hours? So what I do is I graph that on here. We got 10, 11, 12, 13, 14, 15, 16, 17 falls right here. Is that part of our shaded graph? No. So you would not be able to, because 17 is not less than or equal to 15. That's not true. Okay, number 2 of these types of problems. A bus has enough seats for up to 21 people. Right now, there are 13 people on the bus. How many people can fit on the bus? I'm gonna go for my variable first this time. How many more what? How many more people? So I'm gonna say P equals people. You could just say people, you could say people on the bus. Something like that. Now I'm gonna look for my keywords. When I look for words that tell me my inequality symbol, I look by my total, and I see directly to the left of that total, up to. And on here I see up to, it has the less than or equal to symbol. Then looking for keywords for operations. It says right now there are 13 people on the bus. How many more people can fit on the bus? If you look at your equations cheat sheet, more tells you addition. Now let's start writing that inequality. Our total that we have is 21. So I'm going to put the 21 all the way at the right, and then I'm going to put the symbol for the inequality that we discovered, less than or equal to. And then it's an addition problem, so we're going to take our variable p plus the other number, 13. If we solved this, we would get p is less than or equal to 8. Now we're going to answer the question, would 5 more people be able to fit on the bus? So I'm going to plot where 5 is. 5 is right here. That falls in the graph, so yes, they would be able to. Okay, number 3. Sandra needs to beat over 50 levels of Candy Crush to get ahead of Jackie. If she already beat 33 levels, how many more does she have to beat? So I circled my numbers. I'm going to look at the question. How many more does she have to beat? Well, what are we talking about there? We're talking about the levels. So I'm going to say L equals levels. Now let's look for some of those key words. 33 and 50. Maybe it's easier to do it this way. 50 I can see as my total, so I'm going to write that over on the right. Directly to the left of the 50, I see the word over, and if I look on my chart here, I see over. That tells me the greater than symbol, so that goes next to the 50. Just like here, how it's next to the left of the 50. Then we're looking for the word that tells us the operation. I see that it says how many more does she have to beat, just like the previous problem. That is an addition word. So we're going to take our variable L plus the other number of 33. Then you would solve. Here, when you solved, you get that L is greater than 17, and this graph matches that. The question then asks, would Sandra be able to beat 15 levels? Well, if I plot 15 on this graph right here, it is not part of our inequality, so no. All right, last one. Selena is selling bracelets for $4 each. She wants to make at least $44. So there's not a question here, but what are we talking about? She's selling bracelets. So I'm going to say B equals the number of bracelets. I'm going to do this like the last one where I'm going to do the total first. So the total she wants to make is 44, so that I'm going to put that at the end. Then I'm looking for my keywords. Directly to the left of that total, I see at least. And if I look on my chart, at least is right here, which is the greater than or equal to symbol. Now, the other word. I don't see any addition or subtraction words, so I look by my other number and I see the word each, which according to our chart here for multiplication, each is a keyword. So each tells me multiplication. When I'm doing multiplication, I'm writing 4 directly next to my variable, so 4b. We would solve and we'd get that b is greater than or equal to 11. Now we ask ourselves, would Selena be able to sell 16 bracelets? So I gotta find 16. Well, 10, 11, 12, 13, 14, 15, 16 is right here. Does that fall on our graph? Yes.